listeners, and thanks for joining us on another Building IQ 10 on the 10th Tech Podcast, where a range of artificial intelligence, machine learning, and data science topics are explored in 10-minute episodes each 10th of the month. We have the pleasure today to speak again with Building IQ's data scientist, Dr. Ray Xu, who is expert on interpreting complex algorithm results to help him unlock some of the most challenging issues in the buildings industry. Ray, thank you so much for your time today.
Pleasure is mine.
Ray, since we last spoke, I hear you have been working on another optimization control strategy for buildings that helps conserve energy while maintaining tenant comfort. Tell us more about what you're exploring.
It's a room temperature control strategy or planning strategy, which utilizes the Kalman filter to plan the room temperature set point, if you like, 12 hours into the future. So the idea is, this is a bit of a, I would say it's a bit of an innovative use of a Kalman filter, because traditionally Kalman filter is used, it's used in control, but not in the way that this new room temperature control strategy is using it. Traditionally, the Kalman filter is used to fuse sensor data as well as the prediction of a model. The most well-known application will be when we send the lunar module to the moon. We have to know the location of the lunar module, and then maybe there's two different ways of measuring it, and then there's also a way to predict the location of the lunar module based on like a physical model, as in speed, acceleration, etc. And then you just kind of fuse those three things together. Two measurements, trying to measure the same thing, as well as a model that tries to predict the same thing. And Kalman filters provides a way to fuse those three things together, and gives us hopefully a more accurate estimation of where the location of the lunar module is.
That intro to the Kalman filter and lunar module example is helpful, Ray. Tell us more about how BuildingIQ is applying this to buildings.
The way we're using it in this room temperature control strategy is we're also fusing three things, but on the surface there are actually three quite different things. So we're fusing the outside temperature forecast, right? So that's one thing. And we're fusing the fixed set point, which we can change. If you fix it at 22, then it'll be flat line at 22. If you that's degrees Celsius. If you fix it at 23, there'll be a 23, and that's the second thing. And the model is about is the fact that the current room temperature should be the same as the previous room temperature. If you like, this is kind of an inertia model. Whatever you have before, you always keeps on holding that value, right? So this is the model, and that's the three things we're fusing together. And they seem like three very different things, but and we use the result of fuse of those three, the result of the fusion as the room temperature set point for the next 12 hours.
I'm wondering, for comparison, how does using a Kalman filter approach to control strategy differ from how set points are determined today in a building?
Today, on most buildings that doesn't have BuildingIQ platform, the room temperature set point is either fixed, right? So you either fix at 22 and you say, this is your cooling set point, heating set point, and your room temperature cannot. Once it hit the cooling set point, you turn the cooling on. You turn the cooling from the HVAC on. Or if you hit the heating set point, if the actual room temperature hit the heating set point, then you turn the heating on, and things like that. And those things will keep the room temperature within a small range around that fixed set point. So if you happen to engage if your building happens to have, BuildingIQ, what we call PEO, or predictive energy optimization, in place, then you won't have a fixed set point. You will have a optimized set point which goes up and down, and it's planned based on, for one thing, most important, outside temperature. But there's also a few other things, such as the cost, the time of use tariff cost of power, the demand ceiling, if there's one, there's demand charges, and also things like what else? The thermal property of the building, which is estimated from modeling process, right? So in our PEO technology, which is also a room temperature optimization strategy, it's a two-step process. There's a modeling step, which tries to figure out the thermal property of the building or room. And there's a second step, which is the actual optimization, which is like mathematical optimization step, which optimizes the room temperature set point 12 hours into the future, again, based on this model and a few of the other inputs, such as the cost of power and demand charges.
Talk us through what the challenges are for AI-driven room temperature control strategies and the advantages of having a Kalman filter method applied.
So to actually create a good model, we have to have the data, right? Not only just the data that looks good, but also data that is actually, when I say data, I mostly mean the power profile, or historical power profile, which, the power profile actually has to be driven by the room temperature, and as well as outside temperature, right? So there's a few requirements on the quality of the data before we can actually do step one of the modeling process, and there's few requirements for step two as well. So there's a lot of dependencies. I mean, by adopting a simpler approach, which is a Kalman filter, it seems like a step backward, but that's actually exactly what we want, because we want to sort of to be less dependent on those things, such as for example, historical power, because sometimes that piece of information is just not there. So I guess the advantage of having this new room temperature control strategy that's based on Kalman filter is so that when we don't have the data to drive this more advanced, machine learning based room temperature planning strategy, we can still start controlling with a strategy that doesn't require those things.
So to sum it up, it sounds like this approach helps to operate a building more autonomously as a first step toward using machine learning and AI, correct?
For buildings that is just starting on a journey to be fully optimized on room temperature, right? Because when you're starting on a journey, when you're starting to deploy room temperature optimization onto a building, you don't have much data. I mean, for one, if the room temperature is controlled based on the fixed set point, then it's very hard for the machine learning algorithm to learn from a fixed room temperature set point, right? So I guess this Kalman filter version of the room temperature control just gives the building the opportunity to have a to have a room temperature, or to be in an operating mode that is easier for the machine learning algorithm um, to learn from, if you like.
Ray, thanks again for your time today, diving into the new Kalman filter control strategy you're working on. To listen to other Building IQ 10 on the 10th Tech Podcast episodes, or to learn more about Building IQ's technology-enabled services, visit buildingiq.com. Thanks everyone for listening, and we hope you'll join us again next month on the 10th.